Hi, I'm Troy McClure. You've seen me in such fine, quality, epic, APA, environmental science educational videos such as Dams, Good or Bad for Mankind, Part 4, and Biomes, Buy Out Those Biomes, Part 2. Okay. So for this, we are looking at radioactive half-life, looking at radioactive decay. In reality, there are radioactive elements out there that they naturally decay, they naturally break down. As they break down, they give off particles, they also give energy. Commonly known elements that are known to be radioactive. Uranium is probably the most common one. But you can also have radioactive iodine. You can also have plutonium, radium, barium. There's all kinds of elements out there. They do have a radioactive component to them. But typically uranium is probably the most well-known. Plutonium and radium would be awesome, would be great examples. So let's take a look. What is exactly half-life? How would you define it? When radioactive materials decay, they break up. They break in half, so to speak. And when we look at a half-life, we're looking at if I have 1 kilogram of uranium, let's say it takes 10,000 years for its half-life. That means in 10,000 years, instead of having 1 kilogram of uranium, I'm going to have half a kilogram of uranium, for example. And then another 10,000 years, instead of having that half a kilogram of radium, I'm now going to have a 1/4 kilogram of radium from where I started 20,000 years ago. So when we look at a table like this here, there's two ways we can look at this. We look at the fraction that's remaining. We can also look at the percentage that's remaining. Okay? Now, you must understand that the assumption is that the rate of radioactive decay is constant. That doesn't change, because then we would not be able to do these problems here for that. So let's take a look here. So half-lives that elapsed. That when this is a zero half-life, another way to look at it is the start, the beginning. And the fraction that's remaining, 1/1, percentage remaining is 100%. Okay, so if a half-life you're losing half of your material, then at the first half-life that's happened, the fraction that would be remaining is 1/2. The percentage that would be remaining is 50%. Now, you'd say, how in the world would I figure that out? You can take 1 divided by 2 times 100. That's it. So you'd have 50% here. Now notice from 100 to 50%, 50% to 25%. Notice it's breaking down. It's going down by 1/2 each time. That's the half-life they are talking about. 1/1, 1/2. This one will be 1/4 because 1/4 is 1/2 of 1/2, right? And what is half of 1/4? It's 1/8, right? Now we can go and take our faithful calculator right here. Got that on this little cool holster. And I say 1 divided by 8 equals 0.125. You guys could probably hopefully see that, 0.125. I don't know, the lighting is a little weird. And then I can times that by 100, and I got 12.5%. Now if you notice, 12.5%, half of that is 6.25%. Then half of the 1/8 is 1/16. So this is one way to complete the table. Now what about some of the problems that we have with radioactive half-life? Okay. Well, let's see what we have. So here's an example. Canadium has a half-life of 42 seconds. How long will it take for 420 grams of canoodium to decay down to less than 15 grams? Okay, so here's the thing. A half-life of 42 seconds. Great. How long will it take for 420 grams to go down to less than 15? So really what we need to look at is, if we go from 420, what's half of 420? Because that's our first half-life. This is a half-life of 0. This is our half-life. So at a half-life of 0, we're at 420. At a half-life of 1, 2, 3, 4, let's see how far we can go with it. Well, half of 420 is 210, isn't it? Because you divide it by 2. Half of 210 is 105. Half of 105 is 52.5. Are you guys seeing a pattern here? Now we go on to the next one here. 52.5, half of that. Let's see. You can say 26.25. And then we can go to the fifth half-life, right? And half of 26.25 is going to be 13.125. So now we're at less than 15 grams, right? And it's asking how long will it take? So they're asking how many seconds is this going to take? Okay, well I know I'm going through 1, 2, 3, 4, 5. By the time I hit the fifth half-life, I'm less than 15 grams. So it's going to be 5 of these lives. So 42 multiplied by 5 equals about 210 seconds. So it's going to be less than 210 seconds. So roughly 210 seconds that we have here. So that would be our answer. Okay, how long will it take to decay down to less than 15 grams? It's 210 seconds. That's it for that. Okay? All right, let's take a look at another one while we're at it. Okay? Yeah, we've got time. Example, canoodium-88 is decaying after 4 half-lives. What fraction of the original nuclei would remain? Now, a couple of things to think about here. Are we worried about the mass? No. But they're asking us about the fraction. Okay, so let's make this really, really easy. We know that the fraction is going to start out 1 over 1. That's what we started with, right? That's at half-life 0. So we go to half-life 1, that's 1/2. Half-life 2 is 1/4. Half-life 3 is going to be 1 over 8. And then half-life 4 is going to be 1 over 16. Because remember, as you're going through the half-life, it's half of what you have left, not half of what you started. Okay? Because this breaks down 1/2. That means 1/2 of it is gone, it's bye-bye. We have 1/2 that's remaining. Go through another half-life. Now, half of that half is now gone. So we have 1/4 of our original remaining, and then 1/8, and then 1/16. Which is why you cannot actually get down to 0. You'll go to some kind of infinitesimal number, but there's a certain point where the radioactivity is so low, we would not be able to pick it up with our detectors. We just wouldn't. So, let's see what we have here for our next problem here. So we have here the half-life of thugium. 242 is 20 days. What fraction of thugium 242 nuclides, should be nucleides, would be left after 160 days? Now, in this case, you have a complete, you know how many days you have, you also know what's the half-life in days. So really the question to ask is, how many of these half-lives have happened? Well, we have a total of 160 days. And that'll be fine. And then we're going to divide it over 20. Okay? And that's going to give us 8 half-lives. So that means we got 8 half-lives to deal with. So what fraction would we have? Well, you know what? There is a quick and easy way to do this. Because you can go 1 over 2 to the n. Okay? So this formula would be very good where n is in fact the number of half-lives that have accomplished. So what does that mean for us? 1 over 2 times 2 times 2 times 2 times 2 times 2 times 2 all the way up to, so that's what your answer, almost done for the calculation. That's what it means to the end. You're multiplying not 2 times 8. You're not. It's 2 times 2 times 2 times 2 times 2. So from 2, 4, 8, 16, 32, 64, 128, 256. The fraction is 1 over 256. And that's the answer for this next thing. Now, could you go ahead and do this another way? If you didn't know this formula, could you do this another way? Yes. You can go from 1 to 1/2 to 1/4 to 1/8 to 1/16 to 132 to 164 to 1 over 128 to 1 over 256. So you still will come out with the same answer. You're going 1, 2, 3, 4, 5, 6, 7. So this is one way to do it, like this. This is another way to do this. Whichever way you want to do that, that works for you. Okay. I'm some dude, yeah. Troy McClure. Hope this helped you guys out. You take care and God bless.